So whenever you see a problem that has a graph of force versus time and involves velocities, that most certainly is going to be a impulse momentum problem. So here what's going on, we have this 2 kilogram spike, this spike right here, and it's being shot into the ground at 90 meters per second. That's quite fast. It hits the ground and it puts the force on the ground as shown there. And the x-axis is in milliseconds, which are thousandths of a second. So 0.1 milliseconds is 0.0001 seconds. So this is a very, very short duration. And so that force that the spike puts on the ground by Newton's third law, or first law, the one that's an equal and opposite reaction, that's also the force of the ground onto the spike. And so you shoot this into the ground pushes back, and then the spike rebounds back up with a certain velocity. And if you've ever used a jackhammer before, you do feel this jarring up and down from the jackhammer. And so they want to know what's the rebound velocity back up. So this is clearly a momentum problem. So you have the mass of the spike with its original velocity down, plus the integral of this force of the ground over time. That will be the new velocity times the mass going back up. So let's pick a direction as positive. I'm going to take up as positive. So that means this 2 kilogram spike going at 90 meters per second, that's negative momentum because it's going down. And then we're going to do the integral of f dt, which is an impulse of the ground on the spike, which will be up, will equal the new mass, well, I mean, the mass is still 2, times the new velocity, v2, going up. And so what we need to do is get this integral of force dt in terms of Newton seconds. Okay, so the integral of f dt is just the area under the force versus time curve. So I'm not going to get the equations and do the integral. I'm just going to get the area under the force versus time. So the area of this triangle is just 1/2 base times height. So I'm going to change everything to newtons and seconds. So it's 1/2 1500 kilonewtons, so 1000, times the base is 0.4 milliseconds, so that's 3 zeros and a 4, and that comes out to be 300 Newton seconds. So what we have is minus 180, and the units of that are kilograms meters per second plus 300 newtons times second will equal 2 kilograms times the velocity of 2. So it seems like those units are weird until you realize that a kilogram times a meter per second squared is a newton, and so kilogram meter per second is a newton times second. So I'm just going to put the numbers in, and we'll fix the units at the end. So minus 180 plus 300 equals 2v2. So v2 is 60 meters per second